Morgan. Morgan. Okay, so good morning. Now, today we will start the topic of the Vlan Introduction. Now, Vlan is basically stands for the virtual LAN. Vlan stands for the virtual LAN, or we can say virtual local area network. Virtual local area network. So, virtual local area network is used for security purpose. We use that for our security purpose, and it is a large to security. It is a layer 2 security where VLAN divide a single broadcast domain in the multiple broadcast domain, and by default all of the ports of the switch are VLAN 1. So VLAN is basically what? VLAN is basically virtual local area network, and why it is used? It is used for the security purpose. It is also a layer 2 protocol, layer 2 security protocol, where our VLAN divide the single broadcast domain. That means it divide, there will be the single network, so single broadcast domain. By default, all ports of that switch into multiple broadcast domain. That means it divide the single broadcast domain into multiple broadcast domain there. By default, all the ports of the switch will be the VLAN 1. So it's the logical segmentation of the switch network, and based on the functions, project team or the applications of the organization, regardless of the physical location or connections to the network, and all the workstations and server used by the particular work group share the same VLAN, regardless of that physical connection or location. So it is what a workstation in the VLAN group is restricted to communicating with the file server in same VLAN group, and VLAN function by logically segmenting the network, means dividing the network into different broadcast domain. That is what I have said, that it divide the single broadcast domain into the multiple broadcast domain. So it is a logical segmenting. It is the logical segmenting the network into different broadcast domain, so that the packets are only switched between the ports that are designed for the same VLAN. This is the thing. So VLAN is what? VLAN address, scalability, security, and network management. Switches may not breach to any traffic between the VLAN, as this would violate the integrity of the VLAN broadcast domain. Traffic should be only routed between the VLAN. Okay, so VLAN is basically what? It is a virtual local area network that we already discussed, that in our security purpose, what we have done, we divide the single broadcast domain to the multiple broadcast domain. That means dividing a local area network into multiple local area networks, and there what should happen, the packet should be transmitted, and it will be what? It will be designed that packets are only switched between the ports, that the packet will only be switched between the ports that are designated for the same VLAN. So that will be there. So now we will start the topic, that is the name this security as the Kerberos. the security name as the Kerberos. Now, what is the Kerberos? It is basically, this Kerberos is basically a computer network authentication protocol. So, Kerberos is basically a computer network authentication protocol which works on the basis of tickets. That means this is a network authentication protocol which will work on the basis of the ticket to allow the nodes communicating over the non-secure network. Now there will be the multiple nodes should be present. Now it is basically what? It is a authentication protocol, network authentication protocol. And working principle is what? It working principle that it works on the basis of ticket. So it is basically a network authentication protocol which works on the basis of ticket and over the non-secure network. That means there will be the many number of nodes will be communicate. All the nodes are present and all of these nodes are over the non-secure network. That means that network is unsecure. So in this unsecure network, all the nodes are present. Now all the nodes want to prove their identity. Now prove their identity means, let's say as an example, if we take that there is a node present, there is B node present, and there is a C node present. So that's three nodes are present, A, B, and C. Now they are what? They are over a non-secure channel. That means the network they are present, that is unsecure. Now this Kerberos will provide what? This is the computer network authentication protocol, and this authentication protocol works on the basis of ticket. So all the nodes that are present over that non-secure network want to prove their identity. Now if A want to send B the message, then B wants that yes, the message which is coming, that is coming from the A node only. No other node is sending me the message now. So that is to prove the identity. Yes, I am the person. To prove that identity to one another in a secure manner. So this Kerberos is used. So Kerberos will provide what? In the non-secure network when all the nodes are present. So it is that the authentication protocol, it will works on the basis of ticket and it will allow the nodes that is present in this unsecure network, that all the nodes will prove their identity to the secure manner. So client-server model uses the symmetric key module for encryption and decryption process. Kerberos requires a trusted third party. So a third party should be present. In this case, which is we call the key distribution center. So key distribution center is the third party. And this is the trusted third party. This key distribution center has a two different process inside it. One is the authentication server and another one is the ticket granting server. So KDC, key distribution center, will contain two servers inside it. One will be the authentication server, another one is the ticket granting server. These two servers are present inside the key distribution center. Now KDC is basically what it performs. It basically maintains a database of secret key, because we say that it is the third party. So it is what it maintains. It will maintain the database of the secret keys. And those symmetric key means same key. Public and private key should be same. So in a particular key through which we will encrypt that particular, using that particular key, we can decrypt same key. That's why it is called the symmetric key. So those symmetric key we use all of that keys that is shared in the KDC. Now, how it happened, we will see that. Now, let's say there is a user A and there is a user B. Now, we have a third party, that is the KDC present, key distribution center. So, if node A wants to communicate with node B, for communication process, suppose there is a user A and user A has to communicate with the other user B. Then user A will do what? User A will communicate with this third party, this trusted third party, key distribution center. Because they are communicating now, A and B, all of these nodes are on the unsecured channel. So when the communication should happen over the unsecured channel, then there is a probability that there will be the malicious user present in that channel also, who can eavesdrop your message. That means who can see your message and do for your important message, he or she can see it, that the malicious user which is present over the unsecured channel. But let's say node A and node B, they are connected in the unsecured channel, and they want what? They want that the message that they want said, that message that should be sent should be secure, that no one can access that message. No one can access that message. So node A will do what? It will contact with the key distribution center. This is the third party, trusted third party that is present. Now, node A will contact with the KDC or the Kerberos, and once the authentication is complete, yes, KDC says yes, this is the intended A, so okay, there is no problem, then the authentication is completed. So authentication is done. So KDC will do what? KDC will grant the permission. KDC will grant the permission to the user A, and a session key should be done. Session key should be given to the node A, because this is what this key distribution center says, that yes, it is the intended user. So that's why it will share the session key to the node A. So when node A, it get the session key, then it will do what? A will use that particular session key which it receives from the A, which is received from the A, then it will encrypt the message using the session key, encrypt the message, and it will send the transmission. So from node A to node B, the transmission should go. So encrypt that transmission there. So KDC will grant user A session key, and then A will use that session key to encrypt the transmission. So from here, that the communication should be done. So they are communicating over the unsecured channel. So no security is there. So that's why there will be a trusted third party present. And this trusted third party, in that it is maintain a database. So in that database, all of the user list or the database should be present. If it makes the authentication, yes, that A is present there, okay, that means A is intended user. So it will give a session key that is particular for A session key is present there. Let's say the database in A, there will be what? There will be, let's say, the session key is hash. It is stored previously in the KDC. Then for B, it is, let's say, the session key that is $. Like this, it is stored in the key distribution center. So these are matched. This is matched, and if this is matched, then key distribution center will send the session key to A. So when A will receive that session key, using that session key, to encrypt the message and send to the B. So like this, if the transmission is encrypted, then it will be safe for the communicating over the non-secure channel also. So like this, it works. The Kerberos works like this. Now we will see what total, if there sometimes it is given that write short notes on Kerberos, then this is the thing, this is the process they are working. This is the whole process. Now let's say this is the key distribution center present, and in this key distribution center, inside this key distribution center, there is two process we say. One is the authentication server, another one is the ticket granting server. They are two present inside the key distribution center. And this is, let's say this is an user present, this is a user, and this is what, this is the network service. Now user, let's say this is, we name it this user as the A. So let's say user A wants to access this network service. That user A wants to access or wants to gain the access over the network service. Now user A can be present in anywhere, in home or in office. It is present in anywhere, in any location it is present. Now this user will use what? Now this user will obviously use a normal internet. A normal internet this user will use. Now normal internet is a non-secure channel. It is not secure because in that internet all many users are using that. So whom of them whom are the malicious, we cannot say that. So this is the unsecure. That's why this normal internet is the unsecure channel. So now this user wants to access this network service. So to make this the encryption of the user to network services, we use the concept of this Kerberos. Now before the user get access to this network services, the user needs some to have a ticket granting, and that ticket should be present to this network. So that means before starting the communication, what will happen? User will do what? Before accessing that, the user needs some ticket, have a ticket, and that ticket should be present in this network. That ticket should be present in this network, that yes, I am the authenticated user. I am that particular authenticated user, which is authenticated by the third party KDC. So once the network service receives the ticket from this user, which is authenticated by the KDC, the network service will provide the access. Network service will provide the access to this user. So what will happen? First, the user that is present, user will send the message to the KDC, the third party that is present, that yes, I am the user A and need a ticket to get tickets, TGT. That yes, I am that intended user. Yes, I am user A and I need a ticket to get the ticket for communication. That message will be sent to the KDC. Now inside the KDC, there will be all the user list should be present, and with that particular user list, and for each user there will be a particular session key present. Now for user A, let's say hash S, it is written session key. For session key it is stored. For user B, another session key is stored. From user C, another session key is stored. For user D, another session key is stored. So multiple, we have user list there, and for each user we have a session key present there that is stored into the KDC, this third party KDC, key distribution center. So when A will send that, yes, I am the user and I need a ticket to get the ticket. So this message will go to the key distribution center. So internally, this key distribution center is checking its database that, yes, is there any username in our database A? Yes, that means A is present. Yes, that is the intended user. So here, what will happen? So when this will be matched, key distribution center will do what? It will send the message. It will send the message or the response to the user A, that here is the TGT, that the particular thing you are wanting, the TGT, ticket granting ticket, that is here. Because we have compared that, yes, you are the authenticate user. So it will send back the response to the A, that here is the ticket granting ticket. And if you can decrypt this response with your password hash, now it will send that ticket into the encrypted form to say that you will encrypt that particular ticket and see that what is the ticket of which you get. So this will be sent from, this response will be sent from the key distribution center to the A. A receives this encrypted form of response. Now A will do what? After that, it will decrypt the message, decrypt the response which it get from the KDC. So when decrypting, after decrypting, it get the TGT. So it will send again the TGT by saying that, yes, see, it is my, here it is my TGT. Give me a service ticket after checking my decrypted TGT. So it will do what? After decrypting that particular response which is coming from the KDC, it will send again a message to the key distribution center that, yes, I have decrypted that message or the response you have given, and from there I received this TGT. So this is what? This is my TGT. Okay, now give me the service ticket. The service ticket you give me, and that after receiving your service ticket, I will start our communication. I will start my communication then after receiving the service ticket. So this response, it will again send to the key distribution center from the user A. So now KDC will receive this message, that here from message from the A, that a particular is what? A particular TGT it has sent, and saying that please give me the service ticket, and check that the decrypting, after decrypting the message I received, it is correct or not. So it will go to the key distribution center, and the authentication server will do what? It will authenticate that if it is correct, then it will authenticate that and send the response, that, see, here is your service ticket. So the service ticket will be sent to the user A by saying that here is your service ticket. Now when it will receive the service ticket, this service ticket, it will go from here, that using this service ticket, it will send to the network services. So when this through service ticket, the network services happen, after that, the network service will do what? It will send the response. It will send that, okay, it is correct. Now the client server session should continue. The client server session will happen. So this is the thing. This is what we have said, that first user A says that to KDC that please authenticate me, and then give a ticket from the ticket granting server, so that using that particular ticket I can access the network service. This message will go to the KDC. So first, step by step, we will see. First step, user A will do what? User A will send message to KDC that please authenticate me, because in the KDC this trusted third party, that database is maintained, and in database all the user details and their secret keys are stored. So that's why A will communicate directly with that KDC and say that please authenticate me. Yes, you see, you compare that, yes, I am A or not. You compare, and after comparing, authenticate me and give a ticket from the ticket granting server. After that, using that particular ticket, I can access the network service. So when this message will go in the first step, in the second stage, what will happen? The authenticate server, which is present inside the KDC, will send back the response to the user that, yes, here is a TGT. The TGT, ticket granting ticket, it is that. But if you can decrypt this response with your password hash or not, it will depend over you. That, yes, I am sending the message, I am giving you the ticket granting ticket, but now it is your responsibility to decrypt that using the password hash which you have. Now A is the authenticated user because authenticated by the KDC. That's why it sent the encrypted TGT to the our user A. So that's why authentication is done. Yes, A is the authenticate user. It is not the malicious, it is authenticate user. So authentication user, for that it will able to use its own password and decrypt that encrypted TGT and send again to the KDC, key distribution center. So in key distribution center, after encrypting the TGT, the thing that get the decrypted TGT, it get by the user A, will send this decrypted TGT to check again. And though A is the authenticate user, it will decrypt correctly. So it will check and comparison of the TGT by authenticate server. The TGS will now provide the ticket or a session key to the user. So ticket granting service will be now provide because total authentication has done. And then the user will send the service ticket because it will receive the service ticket after that comparison, authentication comparison. So after this, it will send the service ticket to the network. And if the network services authenticated that service ticket, the response will be sent, or the send or client server session will initiates. So client server will do what? Client server will be initiated. Client server session, that means the communication will happen between them now. So this is the process, or this is the thing for the Kerberos. This is the working of the Kerberos or key distribution center. Okay. Clear to everyone?
Yes, sir.
Okay. So this is what? This is the Kerberos concept. Now we will move to the concept of wireless security. So now we'll move the concept to the wireless security. So wireless securities overview. First, we will see the wireless securities overview. So what is the wireless security? Concerns over the wireless security are similar to the found that is in the wired environment. Now, concern is same. The wireless security's concern is same, similar to the that is found in the wired environment. The wired environment which we find, the same concerns is present in the wireless security also. Now security requirements both are same. Both of them have same wireless security requirements. in wired environment and wireless environment. In both cases, security requirements are same. That is, what will be required? Confidentiality, integrity, availability, authenticity, accountability. All of this will require for here also. And most significant source of the risk is underlying the communications medium. Because by the communication medium, that is, we have seen in the Kerberos that all the nodes, we always use the normal network. We always, every time we use the normal network. And that is what? That is the unsecured network, most unsecured network. So communication medium, they are all the nodes will be for the unsecured channel, they will be present. So the source of the risk factor will be there. So most significant source of the risk is over that communications medium, over the network. So this is what the security requirements are. Now, the key factors to higher security risk of wireless networks compared to the wired networks include. Now, some factors. This is the factors that contributing higher security risk. Now, higher security risk more than the wired network. The wireless network has higher security risk compared to the wired networks. Now, what are those? The first, that is the channel. Now, wireless network typically involve broadcast communication. Typically involves the broadcast communication, which is far more susceptible to eavesdropping and jamming than the wired network. Now, broadcasting is what, let's say in a network, let's say if we take this, that in the network, there will be, let's say, broadcasting for, there will be the system present, let's say like that, the systems are present there, A, B and C. A, B and C, like these three systems are present. Now, A is doing what, let's say, now A wants to send a message to B. So A have to know the IP address for that. So it will do what? B will broadcast its message. So B will broadcast to all the nodes, about its IP address. Broadcast its IP address to all the nodes present. So what will happen if there is any malicious user? Because it is broadcasting, that means B is saying, yes, this is my IP address. If you want to send message, then in this IP address you send. And it is communicating or broadcasting to everyone that is present in that network. So what will happen if there is any malicious user present? He or she can also get access to that IP address. So it will send some malicious data or the malicious programs for our hacking. So this is the problem. This is the problem here, that broadcasting problem, we say that is the broadcasting problem. A wireless network typically involves broadcast communication, which is far more susceptible to eavesdropping. That is the eavesdropping. We can say that we can access that because B is sending this message to everyone that is present in that network. So everyone will know that what is B's IP address. So malicious user, if there is any malicious user present in that network, he or she will also get that IP address, know the IP address of the B. So it will do any malicious activity then. But wireless networks are also more vulnerable to the active attacks that exploits vulnerability in the communication protocol. So it is much more vulnerable to the active attacks that happen, and that exploits the vulnerabilities in the communication protocols. Okay, clear till now? It is clear to everyone? Dolly, Golden, Morgan. Okay, so the time is very much less. So in the next class, I will discuss the other probabilities, the other cases. This is the first, we see that this is first contributing factor. The other factors, that the mobility, resource, then accessibility, we will see in the next class. So thank you everyone. I am ending the session.
Thank you, sir.
Okay.